Hello, geometry. Here we go with lesson 5. So a couple reminders here, some vocab that you need to remember. We're moving on to trapezoids and kites. What is a trapezoid? It's a quadrilateral. Notice it's not a parallelogram that has exactly one pair of parallel sides. An isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. A kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. Of the quadrilaterals we study in this unit, these are the only ones that are not parallelograms. They also have special properties. Some of them do, but the properties of parallelograms do not apply to these. I think that probably makes sense because they're not parallelograms. So some properties of trapezoids. Now, these only apply to isosceles trapezoids. You'll see that in both of these. The only thing special about a trapezoid is that the one pair of opposite sides are parallel. That's really about it. Okay, but isosceles trapezoids have a little bit more. The base angles of an isosceles trapezoid are congruent. Identify the base angle that goes with angle B. Then find the measures of each angle. So the base angle associated with angle B is angle C. So these two, they're on the same side, basically. They're kind of on the same side there. In a lot the same way, A and D are also base angles. Now, that's a little bit of a change. You're used to looking at opposite angles on a parallelogram. In a trapezoid, its base angles are congruent. In an isosceles trapezoid. All right, so I'm gonna go ahead and get rid of that. Let's look at those angles. So if the base angles of an isosceles trapezoid are congruent, then I can say that C is 102. Well, then how do I get angles A and B? Well, I have two parallel lines. A and B are same side interior angles. So angle A plus angle B has to add up to 180. Well, I don't know angle A, but I do know angle B is 102. So angle A plus 102 equals 180. So then angle A is 78. And because base angles are congruent, angle D is also 78. All right. That's the first property of trapezoids, isosceles trapezoids. The second property I'm going to prove. What this one says is that the diagonals of an isosceles trapezoid are congruent, just like they are in a rectangle. So we have two quadrilaterals that have congruent diagonals. What's the difference? One is a parallelogram, the other is not. All right, so there's a couple things I gave you in the picture. We want to prove that the diagonals AC and BD are congruent. So I'm going to type here. So first thing I'm going to say is ABCD is an isosceles trapezoid. I didn't give that to you, but I'm going to tell you it's given. Yeah, it's pictured there. I'm going to say AD. Oh, wait, no. I'm going to say AB is congruent to DC. Again, that's given. It's marked on the picture. Now I'm going to say that angle BAD is congruent to angle CDA. And that's base angles of isosceles trapezoid are congruent. Okay. Now I'm going to take some time to redraw these triangles. I'm going to show you what I just did. So BAD, and then so BAD, ADC. All right, so what I've just shown is AB is congruent to DC. Angle BAD, so that angle is congruent to angle CDA because the base angles of an isosceles trapezoid are congruent. I need one more thing to prove that these two triangles are congruent, and that would be AD is congruent to DA. That's reflexive property. That's the overlapping part of those two triangles. AD is in both triangles. So now I can say that the triangles are congruent, right? So triangle ABD is congruent to triangle DAC. No, BCA by side angle side. Since the triangles are congruent, I could then say that BD is congruent to AC by CPCTC. And I've just proven that in an isosceles trapezoid, the diagonals are congruent. Okay. You're not going to have to prove it. I think you probably realize that by now. It's just showing you that what I'm saying is not just being made up. I can prove that that's true. So that's isosceles trapezoids. Now let's move on to kites. There's actually one property of a kite that you need to know, and it is, and I told you in the last lesson, some of you might remember this, the diagonals of a kite are perpendicular. All right, find the measures of each indicated angle. Well, angle 1 is where the diagonals intersect. That's a 90-degree angle. Angle 2, well, I know now that I have a 90 for angle 1, plus the 32 that I gave you, plus angle 2 has to add up to 180. And you should get 58 for angle 2. Angle 3, not as easy, but I'm going to tell you it's 32, and here's why. I can prove those two triangles are congruent. I'm not going to go through the whole proof. I'm going to talk through it, but let's say this is point E in the middle. Well, BE is congruent to itself, right? So that I'm going to put 2 marks there. Now I have HL theorem that proves that triangle ABE and CBE are congruent. Therefore, those two angles here are congruent. So angle 3 is 32. All right. Now I could not say that this angle is 58. A lot of people think that those are also 58. That's not the case because triangle BEC is not congruent. So that means it's not congruent to triangle DEC. Those are not congruent. I'm going to change. Actually, I'm going to get rid of all this. I'm going to show you in this picture using colors. These two triangles are congruent. And these two triangles are congruent, but the red is not congruent to blue. That's the difference. In a rhombus, they would be. In a kite, they are not. Another example of this with kites, it's not a new property, but it is something that kind of follows from it. I'm going to draw a line down the middle there, diagonal, and that line is congruent to itself. So I'm going to do that. I can show you that angles 1 and 2 are equal here because the two triangles are congruent by side, 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 right? Therefore, angle 1 has to equal angle 2 by CPCTC. Okay, now I can find those by doing my I can do my, well, in a quadrilateral, they add up to 360, right? So angle 1 plus angle 2 plus 59 plus 87 has to add up to 360. But the good news is 1 and 2 are equal, so I'll just call those x. So that's 2x plus whatever 59 plus 87 is, 146. Equals 360, subtract 146, 214, so 2x equals 214, divide by 2. They are both 107 degrees. All right. So yeah, that's kites. Last but not least, we are moving on to something called the trapezoid mid-segment theorem. We won't use this a ton, but it is something I do want to show you. So The theorem says a mid-segment of a trapezoid. First of all, it's not the theorem. This is just a definition. A mid-segment of a trapezoid is a segment that joins the midpoints of the non-parallel sides of a trapezoid. So E is the midpoint of AD in that picture. F is the midpoint of BC. They're on the non-parallel sides. That segment connecting them, labeled X, is the midsegment. Now, here's the theorem. The midsegment of a trapezoid is parallel to the bases. The bases are the ones that are parallel to each other. So AB is parallel to DC, and what this is saying is they're all parallel to EF. All three of those lines are parallel to each other. The length of the midsegment is half the sum of the bases. So that's what we're going to do right away is the length, X, find the value of X. So X equals half the sum of the bases. So 21 plus 35. So 21 plus 35 is what, 56? So half of 56 would be 28. Now I'm going to go ahead and erase all this. I'm going to say, okay, let's try something else here. Let's say this right here in the middle was, I don't know, 15. What would be this? Find the value of X in that situation. All right, so this one's a little harder because you have to write an equation. The mid-segment is 15. Is equal to half of the sum of the bases, so X plus 35. So that's the equation. What I'm going to do is I'm going to get rid of the fraction. I'm going to multiply both sides by 2. So I know that the 2 have to add to, oh, whoops. I probably should have chosen a different number. Let me back up here. I'm going to make this 20. I saw what happened. I was going to get a negative number, which is not good. So 20 equals 1/2 X plus 35. Multiplied by 2. I get 40 equals X plus 35. So it means the remaining base would be 5. Okay. All right, there's more to the theorem. And these last two parts look at that. If angle A is 100, what is the measure of DEF? So DEF would be this angle here. Well, those two lines, AB and EF, are parallel, which means 100 and Y are equal because of corresponding angles postulate. So that's 100 degrees. All right, new problem. Angle C is 75. What's the measure of EFC? So EFC would be this one. Well, those two lines are parallel. So that means that those two are same side interior angles. Z plus 75 equals 180. Again, all of this only works with an isosceles, or sorry, a trapezoid. So that's the trapezoid mid-segment theorem. Okay, that's all the properties. The next two lessons deal with some other stuff completely. We're going to start using quadrilaterals, but we've got all the properties now. It's just a matter of keeping them all straight. So that's it.